Hello and good evening everyone. How are you all dear? Is the video audio clear? I welcome you all to India's largest e-learning platform Unacademy, and I welcome you all to my session of EM Wave Propagation. Welcome you all to our channel GATE Conqueror. We are into EM Wave Propagation, subject EMFT. We will be discussing about wave propagation in free space. So lecture number 2 at 5 p.m. today. We have completed lecture number 1. You can just go through the recording, those that missed the session. Just can you give me the clarity about the video and audio? Abba Soni, Bhaskar, Abba Soni, good evening, good evening. Just confirm once. Yeah, thank you, thank you. How are you all? Abba, how are you doing? Just go through the previous session also dear, it will be very useful for you. Before we move in, let me introduce myself. I am GC Reddy, Secured AR 1931. I work as motivation speaker for the past 12 years, Pan India, an expert in field theory and communications. And this is our official Telegram channel for the GATE Conqueror channel. You can just take a screenshot of this. You can join us on Telegram to get personal assistance from all the GATE Conqueror faculty. In EMFT, completed module 1. Separate playlist is available on GATE Conqueror channel with 40 videos recorded. More than 50 hours of lecture is been given exclusively on EMF. I can firmly say that these many hours of lecture, this in detailed explanation, but only EMF, you can never find it in any playlist. We had covered each and every topic in detail, useful for GATE and ESE and other competitive exams. Covered all the derivations, all the theory, all PYQs, lots and loads of practice questions at different levels of difficulty. Just you can go through that playlist available on our channel. Yes, Chandni Prakash, good evening dear. In this, we had covered Maxwell equations for static fields, Maxwell equations for time varying fields, boundary conditions, Poisson's and Laplace equations, their applications, numerous problems on capacitors and inductors, all this we have covered in the series. A playlist is created with 40 videos. We have started EM Wave Propagation today. In the first session, I was giving connectivity between the first module and the second module. I explained all the derivations of Maxwell equations for static fields, Maxwell equations for time varying fields, and we are at the point where when you derive the wave equation or Helmholtz equation from Faraday's law and Maxwell contribution. Good evening, Bhupati Balakrishnan. So we are derived, if you go through our 5 p.m. session, we derived Faraday's law, from which in point form we got del cross E is equal to minus dou B by dou T, and Maxwell contribution where we got del cross H is equal to J plus JD. J is sigma E, conduction current density. JD is dou D by dou T, displacement current density. Now, from these two equations, if you combine, you get Helmholtz equation. Helmholtz equation is nothing but your wave equation. Can anyone tell me why wave equation is required? Anyone? Can anyone tell me why wave equation is required here? How wave equation is important? Bhupati, Bhaskar, Abba, Prakash, anyone? Why wave equation is important for us? For example, if I say x square plus y square is equal to r square, what do you understand by this equation? X square plus y square is equal to r square. If you see this equation, x square plus y square is equal to r square, what do you understand by seeing this equation? Anyone? Abba, Bhaskar, anyone? What is this equation telling you? Polarization. No, that equation refers what? Bhupati. Circle with center 0, 0. Lalita, very good. After a long time, Lalita. Similarly, if you derive wave equation, by seeing wave equation, it will tell you the behavior of a wave. You got my point, everyone? Just like x square plus y square is equal to r square is telling you that it is the equation of a circle with center 0, 0 and radius small r. Similarly, if you derive wave equation, the wave equation will tell you the behavior of the wave. From where can you derive wave equation? We can derive wave equation from Maxwell equations for time varying fields. So in the previous session, I derived Maxwell equations for time varying fields. From that Maxwell equation from time varying fields, we are going to derive wave equation, or else we call it as Helmholtz equation. Got it? So for that, we need Maxwell equations for time varying fields, which are Faraday's law and Maxwell contribution or inconsistency of Ampere's law. The speciality of these two equations is it will give you relation or interdependency between electric field and magnetic field. Electric field and magnetic field. There must be interdependency between electric field and magnetic field if those equations to be a part of a wave. For that, let me discuss about what is an EM wave. what are the characteristics of an EM wave. Then later we will start derivation. Is that clear? Let me discuss about a TEM wave. What is a TEM wave, dear? Transverse electromagnetic wave. How it is important? How do you analyze transverse electromagnetic wave? If you consider a TEM wave propagating along z direction, the wave is propagating along z direction, with electric field along x direction, with electric field along x direction and magnetic field along y direction and magnetic field along y direction electric field is along x direction and magnetic field is along y direction. Such wave is called a transverse electromagnetic wave. Transverse means perpendicular. What are perpendicular? This is electric field along x direction, magnetic field along y direction. Electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. At any instance in a transverse electromagnetic wave, electric field and magnetic field are perpendicular to each other, just like this. And the wave is propagating along the middle finger. Electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Such wave is called a transverse electromagnetic wave. Clear? You can see the same here. You can see here the electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Such a wave is called a TEM wave. Clear? Now, we are deriving such a TEM wave now. We are deriving such a TEM wave now. From where we derive that? From this Maxwell equations for time varying field. So before that, someone define what is a wave. Someone define what is a wave. What is a wave? Yes, dear. Can you define what is a wave? What is a wave? Anyone? Abba, Lalita, Bhupati, anyone? What is a wave? A wave is something which changes its phase with respect to time and space. Such a phenomenon is called as wave. Phenomenon which changes its phase with respect to time and space is called as wave. In a wave, what happens? The phase of the wave will change with respect to two parameters, time and space. To understand this, you need to know about two terms, which are, one second, electromagnetic field travel in a medium is called wave. Okay, Bhupati? Nice try. But what I am trying to tell here, Bhupati, is what exactly the wave is. What is the behavior of a wave? A wave is something that changes its phase with respect to time and space. To understand this, you need to know two terms. One, omega, other, beta. Anyone, what is omega? Anyone, what is omega? What is omega? Anyone, what is omega? Angular velocity. Angular frequency. Good. Okay. Omega stands for angular frequency. What do you mean by that? Angular frequency. Beta. Phase shift constant. Beta is phase shift constant. First, let me talk about omega. What is omega? Angular frequency. What is the difference between frequency and angular frequency then? Are they both same? Beta is phase shift constant. Correct. What is angular frequency? What do you understand by the term angular frequency? Is it frequency at a given angle? See dear, there is a very important discussion. That's the reason why I am giving some time here. This time is very, very important because this is very, very important discussion. Yes, Abba. Frequency you measure in hertz, angular frequency you measure in radian per second, correct. But my question, Abba, here is, frequency means no, Lokesh, no. Frequency means number of times a phenomena is getting repeated. 20 Hz means the phenomena, the wave is getting repeated 20 times in 1 second. So frequency is 20. 200 Hz means frequency, that phenomena is repeating 200 times. That is the meaning of frequency. You understand? High frequency wave, number of repetitions are high. Low frequency wave, number of repetitions are less. In this way, try to understand my question, everyone, please. Lalita, Abba, Bhupati, Lokesh, everyone, I urge everyone to understand this concept very carefully. This concept will decide your understanding of wave propagation. Similar way, what is omega? Frequency means number of times a phenomena is getting repeated. In that way, how can you define omega? Omega refers to angular frequency. What is that omega conveying you? Time period T is equal to 2 pi by omega. Omega is 2 pi by T, where T is time period. 2 pi is number of radians the wave has covered in time period T. See here. If I take phase shift here, if I consider phase shift, here phase shift is 0, here it is pi by 2, here it is pi, here it is 3 pi by 2, here it is 2 pi. This is phase shift. If I consider time period, time is 0, here T by 4, T by 2, 3T by 4, T, where T is time period, time taken to complete one cycle. Okay. Yes, Lokesh, we'll get more clarity, okay? We'll try and get more clarity, okay? Now, wavelength. What is wavelength? The distance covered by the wave to complete one cycle. 0. Lambda by 4, lambda by 2, 3 lambda by 4, lambda. Now if you see here, what is time period? 2 pi by omega. Omega is 2 pi by T. What is this 2 pi? 2 pi radians. Total phase shift covered 360 degrees, 2 pi radian by time period given seconds. That's why omega is radian per second. Got it? First thing I want to clarify is why it is radian per second. Clear? Omega unit, why it is radian per second? Is it clear? Now, if you take omega t, a t is equal to 0. A t is equal to 0. How much is omega t? 0. A t is equal to t by 4. How much is omega t? Omega 2 pi by capital T into time t is t by 4. Pi by 2. When t is 0, when time period t is 0, omega t is 0 phase shift. When t is t by 4 time period, phase shift is pi by 2. Yes, correct. Similarly, when t is t by 2, omega t 2 pi by t into t by 2. Phase shift is pi. See here, t is equal to t by 2. Phase shift is pi. Similarly, if you take t is 3t by 4, phase shift will be 3 pi by 2. T is capital T, phase shift will be 2 pi. You can verify. So what does it mean? What is omega t giving you? Omega t is giving you the change of phase with respect to time. And what I told you, a wave is one which changes its phase with respect to time and space. Who is giving you the change of phase with respect to time? The change of phase with respect to time is given by omega t. So wave, any wave must include this term omega t. Omega is angular frequency which gives you the change of phase with respect to time. Clear? Got it? Now similarly, what is beta? Phase shift constant. Formula 2 pi by lambda. What is 2 pi? Amount of phase shift that is undergoing per one cycle. That is lambda distance. 2 pi radians. Lambda distance in meter. That's the reason why beta is given in radian per meter. What does beta will tell you? The change of phase with respect to space. That's why it is called phase shift constant. It will tell you the amount of phase shift. Beta into, let the wave is propagating in some z direction. So you take beta z. If the wave is propagating in x direction, beta x. Wave is propagating in y direction, beta y. Wave is propagating in z direction, beta z. Now, let me take, at z is 0. How much is beta z? 0. Let us see here. At z is 0. Beta z phase shift 0. at z is lambda by 4, beta z, beta 2 pi by lambda into lambda by 4, pi by 2, pi by 2, z is lambda by 4, phase shift beta z, pi by 2, z is lambda by 2, beta z, 2 pi by lambda into lambda by 2, pi. Z is lambda by 2. It is pi. That means what? Beta z is giving you the change of phase with respect to space. This is when I assume that the wave is propagating in z direction. If it is y, beta y. If it is x, beta x. Okay? So, a wave is one which is changing its phase with respect to both time and space. That means that wave must include two terms. What are those? Omega t and beta z. Omega t will tell you the change of phase with respect to time. Beta z will tell you the change of phase with respect to space. Got it? Is it clear? See, when you don't understand the subject at this level, with this clarity, wave propagation will look very difficult for you. Once you get this basic things cleared, wave propagation will become very interesting, I promise. Because the problem with wave propagation is you cannot by heart wave propagation. You must understand. Any doubts? Any doubts? Let me know. Any doubts? Good. So what is important here is you must try to understand this concept. Once you start understanding this concept, then wave propagation will look very simple for you. Am I right? So I hope you have learned new point today about omega t and beta z. Because most of you had completed EMT. Am I right? One second. Okay. Okay, there is no breaking in the voice, am I right? Voice is clear. Fine. Now, you know about wave. We are into this EM wave, transverse electromagnetic wave. How it is defined? A transverse electromagnetic wave is one where electric field and magnetic field, a TEM wave, is one where electric field and magnetic field are perpendicular to each other and are perpendicular to direction of propagation of wave. It is very clear from this point that in a TEM wave, electric field and magnetic field are perpendicular to each other at any instant, and they are perpendicular to direction of propagation of wave. And one more thing, if the wave is propagating in z direction, which components are present? Ex is present, Hy is present, means which are 0, Ey is 0, Ez is 0. Here Hx is 0, Hz is 0. Similarly, can you tell me some more combinations when the wave is propagating in z direction? Any other combination, can you tell me? Can you tell me any other combination when the wave is propagating in z direction? One is Ex and Hy. Any other combination? Any another combination other than Ex and Hy? Please let me know. Abba, Bhupati, Lalita, Ashrit, Lokesh. Any another combination? Hx and Ey. Hx and Ey. When you have Hx and Ey, Hy is 0, Hz is 0, Ex is 0, Ez is 0. Very good. Very good, Abba. Any other combination? Any other combination? When the wave is propagating in z direction, any other combination? Is there any other combination possible? One combination is EXHY, other combination is HXEY. Other combination, is there any other combination possible? One combination is EXHY, other combination is HXEY. Wave propagating in Z direction. When the wave is propagating in Z direction, is there any other third combination possible? Yes, dear. Is there any other combination possible? No, very good. There is no other combination possible. Only two combinations are possible here. So, in all the two combinations, you can see always Ez is 0, Hz is 0. That means what? What can I say? when a wave is propagating in z direction, the component of electric field, that is Ez, component of electric field and component of magnetic field in that particular direction, that is Ez and Hz, are always zero. This is the second definition. The first definition of a TEM wave is, a TEM wave is one where electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. This is one definition. The second definition is, component of electric field and magnetic field in the direction of propagation is always zero. Means the wave is propagating in z direction, Ez is 0, Hz is 0 always. Such a wave is called a TEM wave. Clear? Okay, dear. Now let us see the wave propagation. In free space. How such a wave propagates in free space. Wave propagation in free space. For free space, how much is conductivity? Epsilon R, relative permittivity, 1. Mu R, relative permeability, 1. How much is sigma? Conductivity. How much is conductivity? Sigma. For free space, 0. If you want to understand how the wave is propagating in free space, what you must do? You must derive wave equation. What is wave equation? Helmholtz equation. From where we derive Helmholtz equation? From Maxwell equation for time varying fields. So consider Maxwell equation for time varying fields. Del cross H is equal to J plus JD. J is conduction current density. JD is displacement current density. J is sigma E, conduction current density. JD is displacement current density, dou D by dou T. Am I right? But for free space, sigma is 0. D is epsilon times C. For free space, epsilon naught times C. Therefore, 0 plus epsilon naught times of dou E by dou T. Now, if you are trying to write this equation in phasor form, what is dou by dou T equivalent in phasor form? Anyone? What is dou by dou T equivalent in phasor form? J omega. J omega. Dou by dou T is J omega. How do you got this? If you take current, time varying current, I of t is equal to Im sin omega t d by dt of I of t, derivative is Im cos omega t into omega. That is Im omega, cos omega t and sin omega t are differentiated by 90 degrees. The change is given by j. Cos omega t can be written as j sin omega t. J omega times Im sin omega t is I of t. Comparing on both sides, dou by dou t is equal to j omega, phasor notation. J omega epsilon naught e. Del cross H is equal to j omega epsilon naught e. Let it be 1. Take the second equation from Faraday's law. Del cross E is equal to minus dou B by dou T. B is mu naught H. Dou by dou T is j omega minus dou by dou T, j omega mu naught H. Let this be 2. So you got two equations I am writing here. Del cross H is equal to j omega epsilon naught E second equation, del cross E is equal to minus j omega mu naught H minus j omega mu naught H. These are two equations you got. Lalita, good. Now from 1, E is equal to del cross H by j omega epsilon naught. Let this be 3. From 2, H is equal to del cross E by minus j omega mu naught. Let this be 4. Now, substituting 4 in 1, del cross E by minus j omega mu naught is j omega epsilon naught into E. This is del is a vector, E is a vector, del cross E is one more vector, del cross some vector by some constant. If a scalar or constant is multiplied to one of the vector in a cross product, you can take it common. I hope you know this rule. I need not explain. If you have any doubt on this, please let me know here itself. If you don't have doubt, you can just say go ahead. If you are having doubt, ask me so that I'll give you clarity. In a cross product, if a constant or a scalar is multiplied to one of the vector, you can take it common. This is a property. This is called the property of determinant. If you are having any doubt, you please raise that you have doubt. Otherwise, you just type go ahead. I am waiting. Please let me know. Good. I can take it common. Del cross of del cross E is minus j into j. J square is minus 1. Minus of minus plus omega into omega. Omega square mu naught epsilon naught E. This is the form. A cross of B cross C. Vector triple product. B into A dot C minus C into A dot B. Back minus cap rule. Here if you take del cross E, here B is del of del dot E, that is A dot C, minus C is E, A dot B is del dot del square, del cross of del cross E is del of del dot E minus del square E. Substituting del of del dot E minus del square E, LHS side, is equal to omega square mu naught epsilon naught E. From this, how much is EDF from equation 3? Del of del dot E is del cross H by j omega epsilon naught minus del square E omega square mu naught epsilon naught E. Can you tell me how much is this value? Yes, dear. How much is that value? Del dot of del cross H. Anyone? First, divergence of curl of any vector. 0. Very good, Abba. Divergence of curl of any vector. 0. So what do you get here? Del square E is equal to this minus I am writing on the other side, minus omega square mu naught epsilon naught E. I'll write on new page. What you got? Del square E is equal to minus omega square mu naught epsilon naught E. Similarly, if we solve in terms of H, we get del square H is equal to minus omega square mu naught epsilon naught H. Let this be 5 and let this be 6. And propagation constant is given by gamma, which is alpha plus j beta, it's given as under root of j omega mu sigma minus omega square mu epsilon. If we consider for free space condition, in free space, sigma is 0, mu is mu naught as mu r is 1, epsilon is epsilon naught, gamma alpha plus j beta, sigma is 0, under root of minus omega square mu naught epsilon naught. From this, gamma square is minus omega square mu naught epsilon naught. Replacing this minus omega square mu naught epsilon naught by gamma square, we get del square E is equal to gamma square E, del square H is equal to gamma square H. These equations are called as Helmholtz equations. What does Helmholtz equations will do? Helmholtz equation will tell you how the wave is propagating. These are also called as wave equations or Helmholtz equations. It will tell you how the wave is propagating. So these two Helmholtz equations are second order differential equation. The general solution for it is given by E is equal to some constant E naught into e power minus gamma. No, let the wave is propagating in z direction, assumption electric field in x direction, magnetic field in y direction. So e power minus gamma z, e power minus gamma z electric field is in x direction into ax. Magnetic field H is equal to some constant H naught e power minus gamma z, wave is propagating in z direction, magnetic field along y direction ay. These are called as solutions for this Helmholtz equation, which will give you the direction of electric field and magnetic field. Now you know gamma is alpha plus j beta, substituting E is equal to E naught into e power minus alpha z into e power minus j beta z of ax. H is H naught into e power minus alpha z e power minus j beta z into ay. These are the expression for electric field and magnetic field for a wave propagating in free space. But I have a small doubt here. The wave is propagating in z direction. Listen carefully. The wave is propagating in z direction. What is this beta z? I told you, no? What is beta z? Anyone please tell me? Electric field is an exponentially decaying function with respect to space. As the wave propagates, the field components will decay exponentially. Okay, what is beta z? It is telling you the change of phase with respect to space. Am I right, Bhuvati? But I told you that wave is something which changes its phase with respect to space and time. Why we are not getting any time component here then? In the solution, why we are not getting any time component? Wave is propagating along z direction, therefore beta z. Okay. Beta z is telling you that change of phase with respect to space. Correct. But I told you the wave is something that changes its phase with respect to both space and time. Why only space variation is given here? What happened to time variation? What happened to time variation? Anyone? Think and tell me, everyone. Anyone? Time is cancelled. Where? No. No, time is not cancelled. What happened to time component? Good try, Bhupati. Anyone? Anyone? Abba? Bhaskar? Anyone? What happened to time component? Why I am not getting any time component? Try. Anyone try? Astrid? What happened to time component? Why there is no time component there? Think. No. Only Bhupati is trying, dear. Others are not trying. Time is equal to phase shift. No. Yes, no, don't know, something. Not perpendicular. No. No. See dear, wave is something which changes its phase with respect to time and space 100%. There is no doubt here, okay? But why I am not getting time component? Because I don't want. Why I don't want? I took phasor components. Initially itself I changed it. Why? Because of the substitution. There is no time. The moment I substituted dou by dou d is equal to j omega, the time factor is gone. That's why in the solution there is no time component, because we had solved phasor components. To make things simple, I had solved phasor components. But you know, wave is something which changes its phase with respect to time and space. This is the solution for the phasor component. If you have time component, you should multiply with e power j omega t. Now it will convert into time component. For E is E naught into e power minus alpha z, e power j of omega t minus beta z into ax. Similarly, h is h naught into e power minus alpha z, e power j of omega t minus beta z into ay. Now, is this clear? Tell me. Everyone, is it clear? Why I am not getting time component? Because I solved phasor components, no? As simple as that. Clear? Now, okay. Now you see here, let me substitute the value of gamma square. See here, gamma square is minus omega square mu naught epsilon naught. Let me solve this. Gamma square is minus omega square mu naught epsilon naught. Gamma square minus 1 j square omega square mu naught epsilon naught. Gamma is j omega into under root of mu naught epsilon naught. But you know, gamma propagation constant is alpha plus j beta is j omega under root mu naught epsilon naught. Comparing on both sides, alpha is equal to 0, beta is omega into under root of mu naught epsilon naught. We all know that when the wave is propagating in free space, attenuation alpha is 0. Why alpha is 0? I am explaining now. This is why alpha is 0. You use it in many subjects, but no one will tell you why alpha is 0. This is a derivation which will tell you alpha is 0. Why alpha is 0? So for free space, you can say alpha is 0 and beta value is omega into under root of mu naught epsilon naught. Clear? As alpha is 0, substituting in these equations, what do you get? E is equal to E naught into, substitute alpha is 0. This will become 1 e power j omega t minus beta z ax, h is h naught into e power j omega t minus beta z ay. These are called wave equations for a wave propagating in free space. Is it clear? Everyone, is it clear? Everyone dear, is it clear? Yes. Now if you see these equations, what this first equation is telling you, the amplitude of electric field is E naught. It is changing its phase with respect to time given by omega t. It is changing its phase with respect to space given by beta z, indicating that omega t indicating that the change of phase with respect to time, beta z indicating that the change of phase with respect to space, and the electric field is in which direction? X direction. Now even though if you don't have this, you can predict, because it's a TEM wave, magnetic field amplitude H naught, change of phase with respect to time omega t, change of phase with respect to space beta z, magnetic field along y direction, electric field along x direction, magnetic field along y direction. That means what? Now you can imagine a wave propagating in z direction, changing its phase with respect to time and space, with electric field along x direction and magnetic field along y direction. Now you tell me, by just seeing this equation, are you able to imagine the wave or not? Just like when you see x square plus y square is equal to r square, you are imagining a circle with the center 0, 0, radius r. By seeing this equation, now are you able to imagine an electromagnetic wave propagating in z direction with electric field along x direction, magnetic field along y direction, with electric field and magnetic field are perpendicular to each other and they are perpendicular to direction of propagation of wave. Are you able to do this or not? Just let me know. Are you able to imagine? Yes. This is called concept. You might have seen this equation 100 times. The more number of times you see this equation, the more confused you get, because you try to by heart this. The problem is we try to by heart this, then wave propagation will become very, very difficult. But the moment you try to understand the concept, then this becomes very interesting, because now you are able to imagine the wave by seeing this equation. Clear? So these are the wave equations for a wave propagating in free space. For free space, alpha is 0, beta is omega into under root of mu naught epsilon naught. You derive now? Yeah. Beta is omega into under root of mu naught epsilon naught. Now, alpha is done, beta is done. Next, I want to find the velocity. Can you tell me what is the velocity with which, or the speed with which the waves are propagating in free space? What is the speed with which the wave is propagating in free space? Anyone? What is the speed by which the wave is propagating in free space? Distance is given in lambda, time is given in time period t, capital T. Multiplying and dividing by 2 pi. Two pi by t, lambda by 2 pi. This is omega into 1 by beta. Therefore, the speed with which the wave propagates is omega by beta. Omega by beta, Lalita, very good. Speed is omega by beta for free space. Omega into under root of mu naught epsilon naught. Omega and omega get cancelled. 1 by under root of mu naught epsilon naught. How much is mu naught? 4 pi into 10 power minus 7 Henry per meter. Epsilon naught is 10 power minus 9 by 36 pi Farad per meter. 1 by under root of 4 pi into 10 power minus 7, 10 power minus 9 by 36 pi. Pi and pi get cancelled. 4 1 time, 4 9 time. 9 will move up. 1 by under root of 1 by 9. 1 by 3 will move up. 3 10 power minus 9 into 10 power minus 7, 10 power minus 16. Under root of 10 power minus 16, 10 power minus 8 will move up 10 power 8. 3 into 10 power 8, which is speed of light in free space, c. So the velocity or the speed of the wave in free space is c, which is 3 into 10 power 8 meter per second. Clear? Formula is also simple. Omega, angular velocity. Radian per second. This is beta. Radian per meter. 1 by radian per meter. Meter per radian. The cancel of meter per second. Velocity. So when the wave is propagating in free space, alpha is 0, beta is omega into under root of mu naught epsilon naught, v velocity 1 by under root of mu naught epsilon naught, omega by beta, which is equal to c, meter per second. You got alpha, beta, velocity. Clear? Everyone, is it clear? Yes, please let me know. Is it clear? Alpha, beta, velocity concept. So the velocity with which the wave propagates in free space is the velocity of light. We derived it now. We derived the formula also, omega by beta. Everyone, is that clear? Good. Lalita, good. Good. Nice. Now we'll go for alpha, beta, velocity is done. Now we'll go for intrinsic impedance. Anyone, what is intrinsic impedance? What is intrinsic impedance? Symbol eta. Intrinsic impedance is defined as the ratio of amplitude of electric field, which is E naught, to the amplitude of magnetic field at any instant of time. See, when a wave is propagating, in a given direction, you'll have electric field and magnetic field perpendicular to each other. The perpendicular to direction of propagation of wave. In this wave, we are having amplitude E naught is the amplitude of electric field. H naught is the amplitude of the magnetic field. At any instant of time, how to understand at any instant of time is, if you take time as constant, at any instant of time, the ratio of electric field here, this is electric field amplitude at this point, same point, magnetic field amplitude. E naught by H naught, if you do, it will give you an impedance. That impedance is called intrinsic impedance of the wave. It's a very depth concept. You should understand it very, very carefully. It's a wonderful concept actually. I'll give you more insight about this concept as the topic proceeds. Initially, you try to understand what is intrinsic impedance. Intrinsic impedance of a wave is the ratio of amplitude of electric field to the amplitude of magnetic field at that instant of time. This value by this value. If you take at this point, this value by this value, it's called the impedance of the wave. Clear? E by H, E by H, E by H. Yes. What does E by H will give you? Amplitude of electric field to the amplitude of magnetic field. Electric field, you are in volt per meter. Magnetic field, you are in ampere per meter formula. This is volt per ampere. What is volt per ampere? Resistance, you are in ohms. V by I, which is R or Z, you are in ohms. Therefore, the ratio of electric field, amplitude of electric field to the amplitude of magnetic field must give you an impedance measured in ohms. That impedance is called intrinsic impedance of the wave. When the wave is propagating in free space, I want to find the intrinsic impedance of the wave. Clear? So if I want to find the intrinsic impedance of a wave in free space given by eta naught, It is the ratio of electric field to the magnetic field amplitude. Given in ohms. Up to this point it is clear. Am I right? Everyone, is it clear up to this point? Clear. How to find this? Let me take the equation. Del cross E is equal to minus dou B by dou T. This is for a wave propagating in Z direction as explained before. Electric field in X direction, magnetic field in Y direction, moving in free space. Implies del cross E, determinant of AX, AY, AZ, dou by dou X, dou by dou Y, dou by dou Z, because del is dou by dou X of AX plus dou by dou Y of AY plus dou by dou Z of AZ. E is EX AX plus EY AY plus EZ AZ. Writing the unit vectors first, AX AY AZ. Coefficients of the first vector dou by dou X, dou by dou Y, dou Z, dou by dou Z. Coefficients of second vector EX, EY, EZ is equal to B is mu naught H minus mu naught into dou H by dou T. Clear? Now, dou by dou T is j omega, replacing, this is minus dou by dou T, j omega mu naught H. And now wave is propagating in Z direction, electric field along X direction, magnetic field along Y direction. Therefore, only E is EX, AX is possible, EY is not there, EZ is not there. EY 0, EZ is 0. Therefore, substituting EY is 0, EZ is 0. Now expanding AX into 0 minus AY, dou by dou X of 0, this is 0, minus dou by dou Z of EZ plus AZ of 0 minus dou by dou Y of EX is equal to minus j omega mu naught H. This is 0 anyways. Minus of minus, this is plus AY of dou by dou Z of EZ dou by dou Z of EX, sorry, yeah, EX, correct, EX, fine, plus AZ of, that is minus AZ of dou by dou Y of minus AZ of dou by dou Y of EX. What is E and H value you got? E is equal to, general solution, E naught into e power j omega t minus beta z of AX. H is H naught into e power j omega t minus beta z ay. This is of the form E is equal to Ex ax, H is equal to Hy ay. So how much is the Ex component you are getting now? E naught into e power j of omega t minus beta z. Dou by of Ex if you are doing is equal to minus j omega mu naught h. Tell me, in this Ex component, is there any y value, y variable? Is there any y variable? Tell me. Is there any y variable? Anyone? Is there any y variable? No y variable means what? This value will become 0. So what is left out? Ay into dou by dou z of Ex is equal to minus j omega mu naught h. Write a new page. Ay into dou by dou z of Ex is equal to minus j omega mu naught h. What is h value? H naught into h value is h naught into e power j of omega t minus beta z of ay. Substituting ay into dou by dou z of Ex is equal to minus j omega mu naught. H value is h naught into e power j of omega t minus beta z of ay, because you know E is equal to E naught into e power j of omega t minus beta z into Ax. H is h naught into e power j of omega t minus beta z into ay. Substituting and cancelling out ay. Dou by dou z of Ex value. This is Ex value. Substitute. E naught into e power j of omega t minus beta z is equal to minus j omega mu naught h naught into e power j of omega t minus beta z. Doing the derivative, this is E naught into e power j of omega t minus beta z. If you do derivative with respect to z, what you will get? E naught into e power j of omega t minus beta z into what? Into something you will get. Please type minus j omega mu naught into h naught e power j of omega t minus beta z. Here into something you will get how much? How much? Anyone? Bhupati, Lalita, how much you'll get? Try to type in the chat box how much you'll get. minus j beta, correct. E naught into e power j of omega t minus beta z minus j omega mu naught is how much? Minus j beta minus j beta j omega t minus beta z j omega t minus e power j omega t minus beta z e power j omega t minus beta z get cancelled out. Minus j and minus j get cancelled out. E naught into beta is omega mu naught into h naught implies E naught by h naught is omega mu naught by beta. But you know E naught by h naught is nothing but eta naught. Intrinsic impedance. Omega mu naught by beta is omega times of under root of mu naught epsilon naught. Omega and omega get cancelled. It is under root of mu naught by epsilon naught. If for eta naught is E naught by h naught, how much you got? Under root of mu naught by epsilon naught. Under root of mu naught 4 pi into 10 power minus 7 epsilon naught 10 power minus 9 by 36 pi. This is under root of 144 pi square into 10 square. That is 120 pi ohm, which is approximately 377 ohm, which is called intrinsic impedance of free space. When a wave is propagating in free space, at any point, the ratio of electric field to magnetic field will be interestingly equal to how much? Under root of mu naught by epsilon naught at all the points, which is constant 377 ohm. What is this 377 ohm? Impedance offered by free space. Means what is happening here? Impedance matching concept. Impedance of the wave is matching with the impedance of the free space. Just like in your circuit theory, impedance matching will happen. Here also impedance matching is happening. Got it? Impedance of the wave is matching with the impedance of the free space. Got it here? That is what you need to understand. Most of the people do not understand this concept that the impedance of the wave is separate, impedance of the free space is separate. Both are getting matched here. That means at each and every point impedance matching is happening and the wave is traveling. That point you need to understand. Clear? Okay? Now, that's about intrinsic impedance. Let's go with vector wave equation. Or wave equation considering the free space model. From Maxwell equations, del cross E is equal to minus dou B by dou T. For free space, B is mu naught H. Del cross E is equal to minus mu naught into dou h by dou t. Taking curl on both sides, del cross of del cross E is equal to minus mu naught into dou by dou t of del cross H. This is again of the form A cross of B cross C, back minus cap rule, B into A dot C minus C into A dot B, del of del dot E minus del square E. You know, we have done so many number of times this sum, right? Is equal to minus mu naught into dou by dou t of del cross H is minus dou B by dou t. Del cross H sigma E plus dou D by dou t. Sorry. We are considering a non-conducting free space region. Non-conducting charge free region. So sigma is 0. Dou by dou t. This is dou by dou t of del cross H is J plus JD. J is sigma E, which is 0 into dou D by dou t. Now here we got del dot E. This is a charge free region. From Gauss law, del dot D is equal to rho V. Charge free region, del dot epsilon naught E is equal to rho V. Charge free region, del dot E is equal to rho V is 0. Del dot E is 0, charge free region. Therefore, this will become 0. Minus del square E is equal to minus mu naught. This is D is epsilon naught E. Minus mu naught epsilon naught dou square E by dou D square. Wave is propagating in z direction. Minus and minus get cancelled. Del square E is equal to mu naught epsilon naught dou square E by dou D square. Wave is propagating in z direction. Therefore, the variation in other directions are cancelled. Dou square E by dou z square is equal to mu naught epsilon naught into dou square E by dou D square. This is called vector wave equation. Under free space condition, charge free space condition, in terms of H, dou square H by dou Z square is equal to mu naught epsilon naught into dou square H by dou T square. Clear? This completes wave propagation in free space. Tomorrow 6:30 AM class will continue with wave propagation in materials. Clear? Unacademy offers two paid platforms. One is Plus subscription. Other is Iconic subscription. In Plus subscription, you got to have the face time of legendary faculties in form of live classes, weekly tests, structured courses, unlimited access, rank improvement batches and crash courses. In Iconic, we have a personal coach for one-on-one guidance, dedicated doubt clearing educators to clear your doubts, preparatory study material, personalized test analysis, study booster sessions and study planner. This is under Iconic subscription. If you go for Plus subscription or Iconic subscription, you can go for a no cost EMI. That means total cost will be divided by number of months without any extra cost. Very much useful for students. And moreover, you can use my code GCR10 to get an extra 10% off. If you're going for Iconic subscription, you get 1:1 mentoring with an assigned mentor for you, increasing your chance of getting a top rank. Moreover, you can use my code GCR10 to increase your chances of topping and getting an extra 10% off with iconic subscription. This All India mock test we are conducting in January. This is the best chance for you to test your mettle and to understand where you stand. Each Sunday we are conducting this. You can enroll this for free by using the code GCR10. These are the special class features where you have interactive live classes for the learners, poll for the learners, raise hand option. You never miss a class when the notification is on. After the class, you can download the lecture notes and you can access anytime and anywhere. This is a very good feature here, Unacademy Ask a Doubt feature, where you can ask unlimited number of doubts, get them clarified in a preferred language, and it is very easy to upload also. These are the new batches here where GATE 2024 for ECE starting on 27th of January, Ascend GATE 2024 for electrical, Ascend GATE 2024 for ECE, Spark GATE 2023 for electrical, Spark GATE 2023 for ECE, Evolve GATE 2023 for ECE, Evolve GATE 2023 for electrical, each one of them starting on 27th of January. And these are the new batches across the different branches, each one of them starting at 27th of January. And you can, for all the batches, you can use my code GCR10 to avail extra 10% off. Thank you all dear. A very big thank you from Unacademy. A very big thank you from GATE Conqueror team. Very big thank you from myself. Have a good time. Let us meet tomorrow at 6:30 AM for EM Wave Propagation 3. Thank you all and good night.